Hello, good morning. Last class we finished review of C++. In today's class we'll be starting with basic concepts of C++. The weightage of this chapter is 1 5 marker you will get and 1 2 marker, that is 7 marks for your theory, and this is a small but completely theoretical chapter wherein you will study different concepts associated with C++, or I can say object oriented programming. And then from the next chapter onwards you will learn the syntax or the actual programming, like how to write a program using that, or what is the syntax and everything you will be learning from the next chapter. But then to understand that, this chapter is very important, so please pay attention and we'll start with the chapter now. The objectives, like today we'll be going through what are different programming techniques, that is procedural programming, object oriented programming and structured programming. Why is object programming important, like how is it superior than the other, basic concepts of OOP, advantages and disadvantages and applications of OOP. So we'll start with procedural technique. So what do you mean by procedural technique? When I say procedure, it also means routines, subroutines or functions. They are all one and the same. It is, what does it contain? It simply contains a series of computational steps which has to be carried out. It works purely on logic of solving a problem. That is, the importance is given to the logic of solving a problem. So I can take an example here, that is to add 4 numbers. What is the logic here? The steps and logic is ask the user to enter 4 numbers, then you have a proper operator, put that, make them work, like find the sum and display the output. This is nothing but logic and step by step execution. So they are written as procedures, and this, at any given point of time during the execution of the program, any procedure can be called by itself or by some other procedures. So the major drawback here is no restriction for accessing the data, like any procedure can access data and any alterations can be done to it. So you may lose the data during the course of the program. We'll just go through the definition again. Any programming language in which the programmer specifies an explicit, what do you mean by that? Explicit means you know what you have to do, that is get 4 numbers. It is an explicit operation, input operation. Same way, explicit sequence, like the sequence or the order of execution should be proper. That is, I cannot put this here and I cannot put it here, because to find the sum I need to have the numbers. So you should have the proper sequence of steps to follow a procedure so that you get a desired result. Just go through this once. Okay. The next one is structured programming. So what do I mean by structured programming? Structured programming is nothing but a program written using 3 constructs, that is sequence, branch and loop. So what do you mean by sequential construct? See, whenever I execute any program, only the main program, you know what is main, right? A main function is loaded in the main memory and the execution is sequential, that is line by line. So that is called the sequential construct. The next is branch. What do you mean by a branch? Branch is nothing but your decision making statements, like if, else. So it is branching. If certain thing is true, you execute certain set of statements. If certain thing is false, then you execute certain other set of statements. So that is called branching, wherein you branch out and depending on the conditions, true or a false value, you execute the statement. So all the statements does not get executed. That is called branch. And then the loop. Loop is nothing but iterative statements. Like you execute certain set of statements again and again. If you want to have a repeated execution, then you use looping. So all this together, any program written with the help of these three basic constructs is nothing but structured programming. You also have functions here, that is different, but then these are the three main constructs which you use to write the program. And then it follows the top-down approach. You know there are two kinds of approaches, that is top-down and bottom up. Structured programming, that is a program written using structured programming language, uses top down approach. That is the main function again is decomposed into lower components below. The example is your C language. Please go through this. Next is the characteristics of structured programming. What are the different characteristics in structured programming? The emphasis is on doing things. What do you mean by that? Like what has to be done? Like main is on functions. That is, you have to repeat something, you have to take in the values, you have to compute something. So emphasis on doing some things, not on the data. Large programs, that is a bigger program, is broken down into number of smaller programs. Like you're computing something very big, or what you can do is you can have that broken down into smaller modules wherein each one computes something and together it's merged together, and in the end you can get the proper result instead of writing everything together. So it is easy to debug like where you're going wrong. If everything is put together in a one large program, then if something goes wrong, the debugging or finding the error also is very difficult. Whereas if you break it down into smaller ones, the finding of error is very easy and it can be reused also. Most of the functions share global data. What do I mean by this? See, data is required to perform any operations on that, correct? And then global data, what do you mean by that? Any data or a variable or a constant which is declared inside a function or a routine cannot be accessed outside. That is, it becomes local to that. But then when you have a large program which is broken down into smaller ones wherein the resultant of one is required or made use of in the other. So it has to be a global data. That is, it has to be declared in such a way that it is accessible to all the functions. Yes. So most of the data is global. That is, it moves freely from function to function. So what is the drawback of that? That is, like, see, there is advantage also, that is you're breaking down into smaller programs. It makes your life easier. Then you can then you share the data so that it moves freely. But then the chances of the data getting corrupted or changed is more, and you have no restriction. Function A can change the data wherein the function B may not want the changed data. So that restriction is not there. It can be changed. So the data transformation, that is, the data can be transformed from one form to another. That is, you cannot restrict the access of data. You cannot say that only B, C, D can access it, A, B cannot access it. That rule you cannot put. Either you can say nobody access it, or it should be shared among everyone. If that is the restriction here, and it employs top-down approach. The main problem of structured programming is there is no restriction. You cannot implement or put a restriction on what programming elements and where the data can be accessed. It moves freely from one function to another. Please go through this. Next is object-oriented programming. When I say object-oriented programming, like you will have lot of object-oriented concepts with the help of which you can write a program. That is a programming paradigm that represents concepts as objects that have data fields and associated procedures known as methods. That is, an object will have its own set of data fields, that is data members, and procedures are nothing but member functions or methods. Here I call function as methods which act on that data. Each or together would be associated with an object. So, and then an object and a class are closely linked to one another. We'll do that in detail now. Example of object-oriented programming is your C++. Again, it has to be noted here, C++ is not a pure object-oriented programming language. When I say pure, what does it mean? That is, I can write a C++ program without using any object-oriented programming concepts. Still, it will work. That is, C++ supports standalone functions, whereas Java is a pure object-oriented programming language. It does not support standalone functions. It has to be, everything has to be put in a class. So, C++, Java, Python, these are some of the examples of object-oriented programming language. We'll start with characteristics of object-oriented programming language. This question, characteristics of OOP can be asked for 5 marks in your exam. Here, the emphasis is on data rather than procedure. In structured programming, the emphasis was on procedure rather than data. Here, the emphasis on data rather than the procedure. So, data is secure. It cannot move freely. Like you can restrict the movement of data from one function to another. You can give the access rights basically. So, data is more secure here in object-oriented programming language. Then the program are divided into number of objects. The program is divided into number of objects and each object is associated with its own data fields and member functions which acts on that data, or I can say methods which acts on that data. Data is hidden and cannot be accessed by an external function. That is, external function is means, suppose I write a class with a set of data and methods to it. So, I can restrict the access of a function which is not the part of the class to access that. It is hidden inside and it cannot be accessed by all the functions of that application. Objects communicate with one another through functions. The communication or the message passing happens with the help of objects. Objects communicate with one another, and then new data and functions, like for example you have an existing application, you can add additional features to it. You need not rewrite the entire application by just adding new data whichever is required to add that extra functionality, and then you add methods or functions which works on the data to get the desired result. So, it is very easy to change or modify or create a new version of the existing application whenever you want, and it follows the bottom-up approach. Structured programming followed the top-down approach, whereas object-oriented programming follows the bottom-up approach. Please go through this. Next, we'll start with basic concepts of OOP. When I say basic concepts, all these concepts are important and we will be studying each concept as a separate chapter in the coming chapters, and we will be making use of that to write an object-oriented program. objects. So what is an object? When I say in a shortest form, I can say it's an instance of a class, or I can say an object is an element which is identifiable entity with some characteristics and behavior. That is, it has its own data and methods associated with it. So then what is a class? Class is something, a blueprint or a prototype from which objects are created. To create an object, you need a class. And a class will not work like you access the elements of a class. You need to have an object. So a class, you can access a class with the help of an object, and objects are created from a class. So we will see what is an object, what is a class. See, I can have a class like this. For example, a class, we'll take your class only, class okay, JE. Let me take class JE. Okay, what will I have there? I will have students over there. So what are the things there? I will have the student registration number. Fine, each student will have a unique student ID or a registration number and a name of the student. And then I can say what are the combination subjects he has taken, because in a JE class you can have bio also, like PCMB or PCMCS. Okay, combination taken by the student, which can be PCMB or PCMCS. This is the data. And then I can say what is your total score on the exams, like you would have taken many exams. Fine, so what is the total score? What is the average score? Like you have done 10 exams, like what is your consistency level? And then I need to display this. Okay, these are the functions. Let me have a class with data members, and this is functions together under JE, wherein each student will have a registration number, a name, and a combination he would have taken. Like what is the combination? Just for my reference I am keeping this, because in the result or this thing I won't be using this. Then what is the total marks? Like you would have written many JE exams. What is the total marks? Like he has scored. What is the average he has scored? Because in one exam he would have taken better, would have scored better, and some he may not have done that very well. And then I need to display his score. So this is the function. I can say this is the method, and this is the data. Fine, this is a class. Then how will I say, well, how will I define an object for this? So when I need to create an object. For example, I have around 50 students, and each student will have all this. Fine. For each student, these things are common, but then each student, the value of these things will be different for each student. It will not be same. So I can have student 1, student 2 like that separately, right? And each student will have a copy of this, then attachment of the data members as well as member functions. That is, these things act on this and get the value. Like what is the, I can also add, then if I have to calculate all this, I can have marks as one more variable, wherein all this combinations and the marks code, and then based on that I will calculate all this and I will display, wherein the object can be student 1, student 2, student 3, which will have the same properties but different values. So this is the general idea, like a idea of an object and a class. Next is encapsulation. What do I mean by encapsulation? So I said you cannot, the emphasis on data. The emphasis is on data. That is, you can restrict the access of data so that it will not be moved freely from function to function. So how do I do that? By the property of encapsulation, that is encapsulating or storing data and function in a single unit called a class is called the encapsulation, because a class will have its own data members and member functions. So in order to achieve the data security, we will be storing data and functions or encapsulating data and functions into a single unit called the class. So this is data encapsulation, storing data and functions in a single unit class is called encapsulation. Next is abstraction. What do you mean by abstraction? The process of representing essential features without including the background details or explanation is called abstraction. For example, I have to print a document. So what do? Like, see, each system is not connected to a printer. Let us assume that you have one printer for your whole floor, and then you are interconnected to that. You need to print a document. Same way others would also be printing. The same simple procedure is you just select print, what are the pages, how many copies, and how do you want it, like what mode, and back to back or new page. All those settings you will do and select the printer, and you will fire the print command. But then after some time you will go and take your printout. Fine, this is what you do. But then you will not be worried about exactly how the data flows to the printer, and then at the same time many people would also be printing. So which one gets printed first, which one gets printed next, like what is the queue, what is the pool, you are not worried about all those things. You just have to give the command correct this one. That is what this means. That is the process of representing only essential features. That is just giving you an option of choosing the document, the style, and then the print command, and collecting the printed document. You don't have to worry about how exactly it moves through the network or the communication or the medium, and how exactly it gets printed and all those stuff, like how it does how does it get converted, how does it wait in the queue and then gets printed. All this you don't have to worry. That is a simple example to explain abstraction. That is the process of representing essential features without including the background details or explanation. This is data abstraction. This is abstraction. The next is polymorphism. This is again an important concept. See, objects, classes, and polymorphism. Encapsulation is a concept which is related to objects only, and again the abstraction is also a concept. You will not be writing any you will not be writing any code for it. And polymorphism is also called as overloading. Then in C++ you have two types. You can have function overloading and operator overloading. So polymorphism, I'll give you a generic example as well as I'll show you how it exactly works, an example in an actual program. So the ability of a message or a function or data to be processed in more than one form, that is poly is having many forms. So polymorphism is an ability of a message or a function data to be processed in more than one form. For example, suppose I have a travel this thing, like different modes of travel, like I have a ship, I have an aeroplane and a bicycle. So in order to start and stop, the basic operations in all the three is start and stop. So the operation stop is same, but then a operation stop, when you use the stopping a bicycle is not same as a aeroplane or a ship. The procedure involved is totally different, but then it is stop only. Like you have to stop it, you stop it, but then the way you have to stop or the different techniques used for achieving that end goal is different. That is what it means, that polymorphism is having many different forms. Another example is, you can take your teacher in Deeksha. Like a teacher acts as a person or a faculty who gives lecture. Apart from that, he also acts as a parent, that is your DP. He acts as a parent in the college, a mentor, a friend, a guide. So one person acting in many different forms is also another example of polymorphism. Now we'll see how does it exactly work or look in a program. For example, I will take the function sum. So when I say sum, then I can add an integer value, I can add a float value, I can add a single character also. When I say character, it will be a single character. It is not a string, because directly I cannot add a string here. Then it can be a long, it can be a double. So these are different data types. And another thing is, I can add a float to an int to a double. Like the number of variables can be different, or the data types of variables can be different. So sum is something which is common to everything. When I am adding, I am finding the sum of it. I can add to real numbers, I can add to integers, long numbers, to characters. I can do all this, but the operation is I am just finding the sum. So how can I write this? Say in one program, that is in a single program, I cannot, in the same scope also, I have to mention here, in the same scope, I cannot have two functions of the same name. That is, the function prototype should not be same in should not be same for two functions in the same scope. So if I say void sum, and again I will say after some time void sum, wherein I can say, or yeah, these are of the same type. You can say that I will be adding two integer character variables here, that is 10 plus 2 I will add, and here I will add A plus B. So this is different, this is different, but then when you call the function sum, how will the compiler know which one you want to execute, whether this or whether this? So there will be an ambiguity. So it will give you an error stating that you cannot have two functions of the same name. It is ambiguous, it will not know which function to execute. So that is what I mean here. The declaration or the prototype of the function should be different. Then only it will allow. So I can say here void sum is 1. The other one is void sum int comma int. Yeah, these two are different. When I call the function without any arguments, it knows very well that it has to execute this. When I call a function with two arguments, wherein I will be passing two arguments, it will know that it needs to execute this. So these two can be in the same scope. Here I say that this is a function without return, without arguments, function without return, with arguments. So these two declaration part or the prototype is different. So this is called function overloading. You can have a look. We'll do this in the coming chapters. Polymorphism is a chapter in itself, wherein it will tell you how to overload and how to call, how to pass arguments in detail. We'll learn this. This is just an example to show you like how is it different and why I cannot have the same function with the same prototype in the same scope. Now we'll do inheritance. So what do you mean by inheritance? A mechanism by which one class acquires the property, that is the data and operations of another class. In simple words, we can say creating one class from another. So why do we need inheritance? How is it useful in this scenario, in programming scenario? Like, let us take an example. For example, your OnePlus phones. Fine. Every 6 months to 1 year, you get a new version of the phone. Like OnePlus 5, 6, 7, 8. So do you think they make a phone from the scratch? What they do is, there will be some basic properties wherein all the phones from all the different versions like 5, 6, 7, 8 will have, and each version they release, they will add new features to it. It can be the camera, this thing, or the screen, the touch screen quality, or the mechanism, or the RAM speed. It can be like double SIM. It can be anything extra added to the existing phone. They do not create a new phone from the scratch. So the new version will have the properties of the old along with its own. So that is called inheritance. That is, you are reusing the properties which is already there, and that is, you are creating something from which is already there, and then you create something new which will acquire the properties of something which is there, and it will have its own properties. So that is called inheritance. The same way in programming also, you create a new class from an existing class. That is something which is common. You put it in one class and you derive a class. Creating a class is nothing but deriving a class from that, and you add additional features to the derived class. So the class from which you create a class is called the base class, and the other one is called the derived class. It can also be called as child class and the parent class. So what is the main advantage of it? Code reusability. That is, it reduces or it eliminates code redundancy. That is, you don't have to repeat that again and again. For example, you have 10 different classes and there are certain set of features which is common to all the 10. So you will not write that same features in all the 10 classes. That is code redundancy or repetition. You are writing the same thing again and again. Instead of that, you can put it in one class and create a class from that, so that it will have that properties, and you can add only the extra properties which is specific to that class. So that is inheritance. Well, there are different types of inheritance. One is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. We have a chapter inheritance, so when we do that, we'll do it in detail. I'll just give you a brief idea how it will look, or whatever I spoke, what does it mean. For example, single inheritance. Okay, I have a class A. Okay, I have a class A. In that I have x is a function. Why is it a function? Why is it a function? Because I have this open and close brackets, and this is how a function looks. Then I also have one more function y. Fine, and I will write it in public. This is my class. So this is how my class looks. And then I will create a class B from A. B from A. This is not the syntax, but I am just giving you an example. That is, my class A has x and y, two functions, and now I will create a class B from A. So this is called the base class or the parent class, and this is called the child or the derived. So, and I will have one more function called void z here. Fine. So now tell me, how many functions are there in B? By seeing this, you feel that A has two functions x and y and B has one function z. But then, since I am deriving or creating a class B from A, what happens is these two gets here also. So it will acquire, B will acquire these two functions like data and function. Since it does not have any data members, it will acquire the function. So totally it will have three functions, that is x and y and z, wherein these two are from A and this is from its own like B. So B will have three member functions in total. So hopefully you have understood the generic idea, like if I have a class A, I have a class B, I derive it, then whatever is the data of A gets inherited to B and then B can have its own properties. This is how the generic idea of inheritance looks. Now we'll start with the types of inheritance. So you got a generic idea what is inheritance. Now we'll do the types of inheritance. The different types of inheritance are single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance and hybrid inheritance. So I will just write a structure how each looks. When I say single inheritance, there will be one base class and one derived class. So this is called single inheritance, wherein you have one base class and one derived class. Where next is multi-level inheritance. So you have one base class, then you derive a class, you have a class A, then from that you derive a class B, and from B I derive a class C. So for C, B is the base class, for B, A is the base class. So that is, you have different levels here. That is, a derived class can be a base class of another class. So what will C have? B acquires the properties of A and it will also have its own properties. And C will have the properties of B and its own, and also the properties of A which it has acquired from B. So C will have the properties directly from B and indirectly from A, because B is derived from A. So B will get the properties of A and it will have its own. Then you derive a class C from B. So it will derive both A and B's properties and it will have its own properties. This is multiple level inheritance, whereas you have different levels here. The next is multiple inheritance. That is, I have a class A, then I have a class B, and then together from this I derive a class C. So class C has two base classes, A and B. So but you have to note here that A and B are not related to one another in any way. So C will have the properties of A as well as C will have the properties of B, and C will have its own properties. When you derive a class from more than one base class, such type of inheritance is called multiple inheritance. That is, a derived class has more than one base class. Such type of inheritance is multiple inheritance. Now we'll do hierarchical inheritance. That is, I have one class A. From that I derive around 4 different classes. So let it be B, C, D, E. So all these are derived classes from A. But then B, C, D is not related to one another in any way. The only commonality here is they have the base class A. So B, C, D, E will have the properties of A along with its own. So they are not related, like C is not related to B, D is not related to B, like they are not related to one another in any way, but all of these will have the properties of A along with its own. Such type of inheritance is called hierarchical inheritance. Now we come to hybrid inheritance. What do you mean by hybrid inheritance? If in a program or an application you have more than one type of inheritance. For example, I have a class and I derive a class B from here, and then from B I will derive two classes C and D. So I have single inheritance and hierarchical inheritance. So together it is hybrid inheritance. The first is single inheritance, that is one base class, one derived class. Multi-level, that is you have different levels wherein a derived class is also a base class to one more class. Then a class, derived class having more than one base classes is multiple inheritance, and then more than one derived class having the same base classes hierarchical, and more than one type of inheritance in a program is hybrid inheritance. So, hope you have understood what is inheritance here. We went through objects, classes, encapsulation, abstraction, polymorphism, nothing but overloading, operator and function, but we will be having only function overloading in your syllabus. Then inheritance. Then next is dynamic binding. So what do you mean by static binding and dynamic binding? There are two types of binding. One is static binding and dynamic binding. Static binding is something which happens during compile time, is static binding. Dynamic is something which happens during the runtime or when the program is executing. During the execution of a program, the binding which happens is called dynamic binding. And why do I need dynamic binding? Now we'll write an example for dynamic binding. Okay, for example, I have a function called area. Okay, and first one is, it is going to return me an integer value, but I am not passing anything to it. The second one is int only, it is going to return me an integer value area, and I am going to pass two integer values to it. Okay, and then I have one more function wherein I have area only, and I am going to pass three integer values to it. Okay, so you can say that the first one without any arguments, second one with two integer arguments, and the third one is 3. So this is nothing but overloading. They are different from one another. Here I will be calculating the area of a square, wherein the value whichever is required will be taken in the function itself. In the second one I am going to find the area of a rectangle, and I will pass the two parameters which is required to find. Here I will be passing the I will be finding the area of a triangle given three sides. So S1, S2, S3 is passed here. Now I will ask the user which area he needs to find. If the user chooses option 1, I will call this function. If the user chooses option 2, I will call this, and if the user chooses option 3, I will call this. So depending on the choice of the user, I will call these functions. So until you execute it, you will not know what the user is going to choose. So when during runtime or during the execution of the program, the user chooses one, you need to execute this. So you should link it here, and then you need to execute. During that, binding happens during runtime only, because I will not know what the user will choose during compile time. So when I execute it, depending on the user's choice, I will call that particular function and I will execute. This is called dynamic binding, and it is related with polymorphism and inheritance. Hope you have understood this concept. The next is advantages of object-oriented programming. Advantages are also very important. It will come for 5 marks. The first one is simplicity. What do you mean by simplicity? It means that the complexity is reduced in a program and it is very clear and simple because it is in the form of objects. So it is very clear, simple, you know how the data flows, everything, and it is unambiguous. So that is one thing. The next one is modularity. What do you mean by modularity? That is like you have modules together and it is like in the form of objects. So object forms a separate entity and you keep the objects and each object is together linked and an entire application is built. So you have different parts or objects, that is modularity. The next one is extensibility. What do you mean by extensibility? Adding new features or responding to changing operating environments, of defining new objects by extending existing one. That is, to the existing one you can define new objects and add it. That is called extensibility. That is, you can add new features to the existing one. That is, you don't have to recreate anything from the scratch. Next is flexibility. That is, an object-oriented program is very flexible in accommodating different situations because the interaction patterns among the objects can be changed without modifying the objects. That is, how the objects communicate with one another can be changed without changing the object. That is called flexibility. The next and the last one is reusability. What do you mean by reusability? That is, the objects can be reused in different programs, not only one, but it can be reused in different programs. Now, maintainability. What do you mean by maintainability? Objects can be maintained separately is maintainability. That is, you can maintain it separately, you can locate, fix the problems object wise. That is easy to maintain. That is called maintainability. The next is what is the disadvantages of object-oriented programming? The first one is larger program size. Object-oriented programs involve more lines of code than the procedural programs, because more lines, procedural programs, they are just set of procedures, just you call. But here you have a lot of encapsulate properties which you need to implement. So the lines of code will be more. But then again it is more efficient also. That is why large program size is one of the disadvantage of that. Then it is slower programs. Why is it slow? Because it is more, the instructions has to be executed. Then other aspects of object-oriented programs demand more system resources. Since it demands more system resources, the programs are slower, not suitable for all types of problems. Like you cannot write it, you can write a simpler program for simple programs, actually problems. You don't have to write always an object-oriented program. Then polymorphism and dynamic binding require long processing time. Why does it require? Because the during runtime the binding happens, so the processing time is more, and then after that the function call, then you need to bind and execute. So that is why it is an overhead on the compiler time. It is overhead on the processor time. Applications of object-oriented programming. What are the applications? Here you don't have to explain like how does it work. You just have to mention where it is used. They are used in real-time system design, simulation and modeling system, object-oriented database, distributed database, client-server systems, multimedia, CAD/CAM systems, artificial intelligence and expert systems. So these are some of the applications, and it's a 5 marker, so you need to write this in the exam. The next is procedural programming versus object oriented programming. Again, this is a 5 marker question which is repeatedly asked in the exam. So we'll just go through this. In procedure oriented programming, large programs are divided into smaller programs known as functions. So the programs are divided into smaller programs such as functions. Here it is divided into objects. In object oriented programming, it is divided into objects. In procedure oriented programming, it is divided into functions. Here the data is not hidden. That we discussed why we cannot hide data, and which can be accessed by any function, and it can be altered also. That is, it uses global data. Most of the programs use global data, wherein the data can move freely between the functions, whereas here the data is hidden and cannot be accessed. That is encapsulation. Data and methods are hidden inside a class. So data is hidden and cannot be accessed by external functions. This follows top-down approach, whereas this follows bottom-up approach. And we discussed what is top-down and bottom-up also. Data may communicate with each other through functions. How do they communicate? Means passing from one function to another. That is, data communicates with each other through functions, whereas here it happens through objects. That is, objects communicate with each other through functions. Then emphasis is on the procedure or the function rather than the data. Here the emphasis is on the data rather than the procedure. So these are some of the differences between procedural programming and the object oriented programming. Please have a look. The next is homework questions. These questions are from your question papers, which is repeatedly asked. So briefly discuss the classes of OOP, then explain the advantages, applications and limitations and characteristics. These are all 5 mark questions which is repeatedly asked. Then now we'll do some 1 marker questions, which is again the exam asked questions from this chapter, because we come to an end of this chapter, which is a 7 mark chapter. You will get 1 2 marker and 1 5 marker here. These are the 5 mark questions. Now I will discuss the 2 marker ones. Like they can ask you what is an object, what is a class. So what is define a class? Define the term class, define the term object. Then they can ask you define data abstraction, encapsulation, polymorphism. So you should be thorough with each of the OOPs property. That is, what are the different properties of OOPs can also be asked, and you should be thorough with different OOPs properties. Data encapsulation, polymorphism. Again, polymorphism is nothing but overloading. You have of 2 types, you have of 2 types, that is operator and function overloading. Then what is inheritance? The types of inheritance. Again, what is a base class, derived class, which is related to inheritance. What is dynamic binding, which is again a OOPs property. And then what is data hiding? So that is, data hiding is what is used in object oriented programming to hide information within the computer code. Then what are the advantages, disadvantages, differences, then explain a class. All this will be asked for 5 mark. So we come to an end of this chapter. So let me have a quick recap. What we did, what are the different types of programming techniques, that is procedure oriented programming, structure oriented programming and object oriented programming. So how is object oriented programming different than the other two? What are the advantages, disadvantages and what are the different concepts of object oriented programming? And we just had a brief introduction like what it means. We didn't do any actual programming here. We just understood the structure of it, like what exactly and how it works, what it exactly means and how it works, and then the comparison between the two programming languages. So from next class we'll start with classes and objects, wherein we will study in depth about the difference between the structure and a class. We have done already structure in the last chapter. This chapter we did class, the previous chapter we did structure. The next chapter will be studying the difference between the two and how do you declare an object, create an object, and then how you access the members of a class. We'll study about access specifiers like private, protected and public. Then we'll study about functions inside, outside the class, like you declare a function inside, how to define it outside, and then what is like how the memory is allocated for the objects data members, how it's allocated for the function, then array of class objects and using objects as arguments. Till now we passed arguments, like wherein we passed for integer, character, float, we did that. So how can you pass an object as an argument? All this we'll do in the next chapter. So today's chapter, we'll be completing this chapter today. Have a nice day. See you tomorrow.